Manual transmission, or simply a gearbox, has been serving automobiles well for many decades. Even today, it's the most popular form of transmission. In this video, we'll give a conceptual introduction on the workings of an actual manual transmission with a reverse gear. The basic question is why transmission is required in an automobile. The power generated by the engine flows through the transmission before it reaches the drive wheels. The basic function of the transmission is to control the speed and torque available to the drive wheels for different driving conditions. For example, if you want to climb a hill, you need more torque. By reducing the speed at the transmission, we will be able to achieve higher torque for the same power input. Conversely, if the torque demand is low, we can increase the transmission speed. Now let's look at its inner workings. Manual transmissions work on the simple principle of gear ratio. A basic transmission mechanism is shown here. Here, the input and output shafts are connected through a counter shaft. A 3-speed mechanism will look like this. It is clear that just by sliding the gears, we can achieve different transmission ratios. This transmission is more specifically called a sliding mesh transmission. They are good for controlling the speed, but they have an inherent disadvantage. It's quite tricky to slide from one gear and engage with another gear. The constant mesh transmission permanently solves this problem. Here, the gears are always in mesh, but with a major difference. Here, the output gears are loosely connected to the shaft. If we connect only one gear to the shaft at a time, the shaft will have the speed of the connected gear. With the help of a hypothetical connector, different gear ratios are illustrated here. It is interesting to note that in fourth gear, the input and output shafts are directly connected. The art of locking a loosely held gear to the shaft effectively and smoothly lies at the heart of the manual transmission. Let's see how this is done in actual practice. First of all, the main shaft gears have a synchronizer cone teeth arrangement. A hub is fixed to the shaft. A sleeve that is free to slide over the hub is also used in this system. It is clear that, if the sleeve gets connected with the teeth of the synchronizer cone, the gear and shaft will turn together, or the desired locking action will be achieved. But during the gearbox operation, the shaft and gear will be rotating at different speeds, so such a locking action is not an easy task. A synchronizer ring helps to match the speed of the gear with that of the shaft. The synchronizer ring is capable of rotating along with the hub, but is free to slide axially. Before moving the sleeve, the clutch pedal is pressed. This way, power flow to the gear is discontinued. When we move the sleeve will press the synchronizer ring against the cone. Due to the high frictional force between the synchronizer ring and cone, the speed of the gear will become the same as the shaft. At this time, the sleeve can be slid in further and it will get locked with the gear. Thus, the gear gets locked with the shaft in an efficient and smooth way. The same mechanism is employed to shift to other gears, such as first gear, third gear, and fourth gear. You can also see the gear lever changing mechanism. A fifth gear is used to turn the output shaft at a higher speed than the input shaft. Now let's see how the reverse gear works. The reverse gear uses a 3-gear arrangement, as shown. Out of those, one is the idle gear. When the idle gear is pushed and connected to the other 2 gears, the output shaft will turn in the reverse direction. Please note here that the reverse gear does not have a synchronizer ring mechanism. This means that the gearbox rotation has to stop completely before applying the reverse gear. Thank you for watching the video.